Hello, I'm Zino Kova, and along with Piotr Kroll, I'm going to talk to you today about Open Security Training 2, or OST2 for short. So first, what is OST2? Well, it is a free as in beer, place where you can go take computer security training online. It is also a Libra. It is open source content. The content is generally licensed under things like Creative Commons with attribution, share alike type licenses, as well as appropriate open licenses for any source code used in labs and things like that. It's open access, so anyone can just go to the site and sign up. And it is open access learning paths. It is not just individual classes, but we try to structure all of the classes into learning paths. And you'll see as we go just how structured those can get. It is also run on top of the Open edX learning management system, which is the thing used by places like MIT or Harvard in order to run their online classes. So when thinking about how open source developers could benefit from Open Security Training 2, I came up with 4 general categories. The first is that if you happen to be a developer of a security-specific project, I just grabbed some random project names that came to mind. If you're a developer of one of those sort of projects, we would of course love to have classes on your project, either how to use it or how it works internally. And in so doing, you can help bootstrap more users and potentially contributors to your project. Another way that OST2 could help is by doing a Security Engineer++. So we have the capability to bootstrap engineers, to level up existing engineers, to create new engineers and new and differentiated types of security engineers, and so that can potentially help a project. Another thing is that I am very literally right now, at this moment, at all of the time except for when I'm recording this, I'm working on a new class called Vulnerabilities 1001. This is a secure development class meant for people who program in unsafe languages like C, C++, and this class will provide a way for developers to get a much better handle on specific implementation vulnerabilities, and specifically the memory corruption type that are the most common things that when you see the statistics from Google, Microsoft, etc. These are the things that are really beating people up and occurring in all code bases everywhere. So I'm going to be teaching more about those vulnerability classes and how to avoid them. And finally, of course, there is potential to move away from things like unsafe languages themselves, super complex projects and closed projects, to safer, simpler, and more open project. Of course, we can all get behind those kind of things, right? So let's drill into each of those 4 things. So for the first one, I said that if you're working on a security type project, something that is specifically for security, then it makes perfect sense to me that something like how to use your project or how your project works internally would be applicable for open security training classes. So let's take a couple examples. So for the USB Armory Mark II, which is made by Inverse Path, now part of F-Secure, this is an open hardware project for a secure USB drive type device. But of course it's way more than that because they designed it to be sort of securely designed and to be an open platform for other experimentation. And although it can do things like having a encrypted file system with true 2-factor authentication and stuff like that, it's also useful as an experimental platform for doing things like learning how to write secure bootloaders and firmware in Go, or building a trusted execution environment using things like TrustZone on an ARM SoC, a system on a chip. So USB Armory is a super cool project that I want to see more people using, and I think that, I've spoken with Andrea Barasani, and I think that in the future, if people can just go and check out a class on this, it'll provide, additional benefits both for more users as well as more contributors to USB Armory. Another example of this sort of thing is the Luna project. You can see I have a little bit of bias towards open hardware projects that I've done my outreach to thus far. So Luna is a new crowdfunded project. So USB Armory has been around for a few years now. Luna, on the other hand, is newly crowdfunded, still under development, going to be released in the near future, modulo supply chain type issues. And basically this is a board for experimenting with USB protocol analysis and interposition and things like that. And this is once again a thing that's built on a bunch of open source software, and it's the kind of thing that allows people to tinker and to build new security tools on top of it. And again, I think this is the kind of thing where a lot of people will benefit once there are classes that say, hey, we've got a new tool that can do new types of capabilities, so check it out and take the class and see all the kind of cool things you can do with hacking on USB devices. And of course, tooling obviously always leads to improvements of the state of the art as more people get easier ways to interact with things that they would potentially like to attack. All right, so that was just a couple of quick examples of a security specific project that in the future could have a class, whether it's how to use the thing or how it works. But if you are some completely different security project, again, we'd love to hear about your kind of classes. We'd love to have your kind of classes at Open Security Training. Even if you're not specifically on a security project, as you'll see later on, some things like coreboot, which Piotr will be talking about, it's not specifically a security project, but you can see how things like that have applicability to designing more secure systems, and therefore sometimes just fundamental things are appropriate for teaching at Open Security Training as well. So back to our 4 topics. What about Security++? What are we trying to go for there? Well, in this picture, by analogy, this is the security engineer. This is the overworked developers. Just, it's a good face right there. And these are the slings and arrows of outrageous fortune, aka the findings from vulnerability assessors. So adding security engineers can help defend the developers from having to do these sort of hair on fire moments when one of those flaming arrows catches you and you have to respond to it. So what can we do to help do this kind of Security++? Well, there's 2 kind of sub-cases of that. The first is leveling up junior engineers on fundamental technologies, not even necessarily security technologies, although the fundamentals that you teach them might ultimately be applicable to security learning paths. And so these can be things like learning debuggers, assembly, OS architecture, stuff like that, so they can learn those more deeply. And of course, if there's fundamentals of your particular project and you'd like to upgrade your particular junior engineers, then providing a class to Open Security Training can definitely help with that. So the thing is, behind the scenes, I have extremely large mega maps of all sorts of different classes that I think would be appropriate for Open Security Training and that I'd like to have eventually. I don't post this kind of stuff because I don't want to overpromise. I post this kind of stuff, just the very simplified versions of things so that you know what we're kind of looking for. So for instance, when I'm teaching assembly, there are other classes that play into that. Things like the class on how to set up your Windows VM and your Visual Studio that then you use to source level debug some assembly. Or optional paths for setting up an Ubuntu VM and GDB in order to look at assembly in GDB instead. Now that's the sort of simplified path, and then I have more realistic paths that in this particular class it is started from Windows and Visual Studio into assembly content, and then actually once you've learned the assembly, that's when you go back and learn your debuggers, because it's not as good to try to learn a debugger before you even can read assembly. So then there's options for whether you want to learn WinDebug or Ubuntu plus GDB. And ultimately, we do an exercise in the class called the Bomb Lab from Carnegie Mellon, which is basically a reverse engineering exercise where you're given a completely opaque binary blob, and it asks for some sort of input, and you have to figure out what sort of input it requests via reverse engineering it. Now, that was, an example of how the Assembly 1001 works for the general case for like systems programmers, things like that. There are also additional modules being worked on that are more for unlocking reverse engineering type paths, where a reverse engineer, rather than using WinDebug or GDB, they might want to jump right into one of these reverse engineering type multi-tools like IDA or Ghidra, and then do the Bomb Lab in that instead. So the big thing that I'm very into for Open Security Training is reuse and modularization. So just like good software is designed in a modular fashion, I want to design learning paths so that we have content that can be reusable in many different places. So if that was how you get to something like learning assembly, Then from assembly, you might move on to things like OS internals, Architecture 2001 OS internals. That depends on assembly because I want you to know assembly before you get into it. And also currently it depends on the Windows path of WinDebug and intermediate WinDebug because I only know how to debug a kernel in Windows. I don't know how to do it in GDB or KDB for Linux. So this is the current path. You must go the Windows route. But, a desirable path would be if someone else out there who knows how to use KDB or GDB, I don't know which it is, to debug a Linux kernel, well, we could take this mostly OS agnostic class that is mostly about learning, just general Intel things like paging, segmentation, interrupts, debug hardware, breakpoints, control registers, things like that, port I/O. These are just general concepts that, OS internals, virtualization firmware type people need to know, but because of my personal limitations of only knowing how to kernel debug in Windows, we're doing Windows debugging right now. If someone else would like to contribute the equivalent class on doing kernel debugging in Linux, then we could just tack in some Linux examples and you could do the same sort of thing in a much more Linuxy sort of way. You can see we're already most of the way there thanks to the reutilization of our instructions on setting up Ubuntu VM and GDB1. So there's not actually that much extra to make this sort of more open source friendly. So moving on from Architecture 2001 as a general class that talks about generalisms of how Intel paging, segmentation, port I/O, hardware breakpoints, control registers, and that sort of thing work, there is a desire to then get into OS specific variants of that. So for instance, this talks generically about how paging works, and then because I only know Windows kernel debugging, it shows an example in Windows kernel debugger. But you could imagine that there is further details that could be dug into specifically about how Windows paging works, Windows interrupt descriptor table, Windows hardware debugging, port I/O, things like that. And so the idea is that these classes in this column right here would be the take that material and provide the OS specific further details about how that particular OS has chosen to implement some of these Intel mechanisms that are, OS agnostic. But then following on from that would be classes that don't relate back to this and then just become whatever you want to talk about for Windows, scheduling, for instance, thread scheduling, process scheduling, whatever you want to talk about for user mode callbacks or, the GDI interface. So while I'm somewhat qualified to teach this, I would like someone else to do it who can also do this because, we always benefit from consistency of explanation when people teach related classes. I am in no way qualified to teach the Linux or Mac OS versions of these classes. So these are desired classes that we'd love to see in the future. Now, once again, Architecture 2001 does serve as a nice base for other things like the virtualization classes, because you need to know about things like paging and port I/O and model-specific registers and hardware breakpoints in order to virtualize it. So this serves as a nice base for future classes on virtualization. And then later on, there is a instructor who's started creating a class on a debugger called HyperDebug, which is a virtualization-based debugger. And while that debugger would technically benefit from, having these Windows internals classes, it's not strictly required. But what about firmware? Well, I'm a firmware kind of person. And right now we have the Architecture 4001, which builds on 2001 because, for instance, you need to know how segmentation works in real mode on an Intel CPU at the reset vector in order to understand the first little bits of assembly you would find in a BIOS. So Architecture 4001 builds on that. It also includes the utilization of the Symix debugger from Intel in order to look at the reset vector without having to put hands on real hardware or to look at system management mode without having, again, a hardware debugger or an instrumented firmware. So again, 4001 is trying to be sort of the Intel firmware agnostic view of the world where we talk about things like protected range registers or system management mode or some, PCI and how port I/O relates to PCIe at the reset vector and all that kind of thing. So this is meant to be sort of firmware agnostic, and the goal is then to have follow-on classes that say, okay, now let's talk to you about things like UEFI firmware, or let's talk to you about things like coreboot, which are ultimately going to utilize some of these Intel technologies. And so in terms of what we have right now, we have the introductory coreboot class has already been made by the 3M Dev instructors. and they are currently working on the UEFI introduction class as well. And they had started working on the coreboot class, the hands-on class, where you actually put your hands on hardware, install coreboot into physical hardware. But we haven't quite figured out yet at Open Security Training our best practices for recording with a camera, like actual physical chunks of hardware. So I had to back off that and start working on this. Now, what is desired, and this is where we get into all the nice things I'd like to see, but we don't have yet. It would be nice to have something that talked about legacy BIOS interrupt vectors and things like that, and how those are used to provide access to old hard drives and video and stuff like that. That's nice to have. That's being decreasingly relevant in modern times. So no one's working at that right now, but it would be nice if someone would like to work on it. Now, in the same way that the 3MDev folks are working on, the introductory UEFI, I would expect that the UEFI hands-on would come shortly thereafter. And, they are working on these to some degree, but I don't want to color them in to overpromise or anything like that for them. Furthermore, I've seen their curriculum for, UEFI internals, and, it looked so good and it had so much content that I said, you really need to break that up. We need an internals 1, which should be more for beginners, people who don't know anything about UEFI, and UEFI internals 2, which perhaps could provide some more of the content to people who do know about UEFI. Maybe they could just jump right in right there and dig deeper into some of the security specific elements of it. And the same goes for coreboot. You could have internals 1 and 2. Then we have things like the master boot record, which had applicability in terms of the firmware boot chain in the context of legacy BIOS. And once you have things like master boot record, then you can go on to learning about things like bootkits. Now, realistically, I don't know that the MBR will actually exist in its own class. It'll probably be incorporated into a future bootkits class as the starting version, but maybe we can break it out later on. All right, well, after you get done with some of that firmware type stuff, you might imagine that you would go on to bootloaders, whether that's grub, winload, boot.efi in the context of Macs, whatever it is. Bootloader classes would be highly appropriate and would again be something that would help serve bootkits classes. Then you might want to move on to secure boots, and there's probably going to be some amount of shared content, just generic secure boot type things, and before you move on to UEFI specific implementations of secure boot or coreboot specific implementations. And once you've got a secure boot, then you want to talk about measured boot, right? And so to cover something like a measured boot class, you would imagine that you would probably want something like a TPM class, TPM measured boot class, and then the UEFI specific instantiation of a TPM measured boot. And likewise for coreboot, right? So these are all kind of things. They're all in, some level of, development, wishing. We've got certain number of people who have capability to teach these classes, but some of them I don't want to put down as, underdeveloping yet. And once you get to the TPM class, well, of course, then you have to have a trusted computing section, right? Well, I started drawing these sort of diagrams for trusted computing, but then I decided that was too much work for stuff that's too far off, so let's just go look at the mega map briefly, shall we? So what sort of topics might we have for trusted computing? Well, of course, TPMs, but also I just wanted to put these placeholders for things like smart cards and secure elements, hardware security modules, neither of which I've ever actually dealt with, but obviously, if you want to talk about building a trustworthy PKI system, you're probably going to need some HSMs in there somewhere, and of course, smart cards in the context of mobile security and embedded security, secure elements, things like that. Highly important. I just don't know enough to fill out the rest of those chains. So another thing that you could always help with for open security training is to help provide maps, fill in the map for stuff that I don't know about, to help at least get something on the page so that we can go out and try to find who might be a good instructor. So then over on the TPM side of the world, we of course have the TPM basics, and you might have intermediate and advanced, getting to more and more obscure TPM type mechanisms and functionalities. But then we could also have measured boot like we were showing before. And while you could have measured boot in the context of just a general, attestation system or something like that, you can also have measured boot in the context of full disk encryption protection. So for instance, BitLocker plus TPM or Linux's use of LUX. So then we start getting into, what does trust computing mean in the context of specific vendors? And you have to start considering vendor-specific technologies, things like the Intel Converged Security and Management Engine, the AMD Platform Security Processor, ARM Trust Zone, and then all of the little, vendor trying to do a little better by themselves type things. SureStart, Dell's Embedded Controller, Amazon Nitro, Google Titan, Apple's CEP, MS's Pluton, and all those kind of things. So don't have much written out there, but the basic point is these are all general technologies that are trying to provide some additional trust in their computing. Back to the Intel, we can have these buildup of CSME that has applicability to Intel's authenticated code modules used in things like trusted execution technology used in things like T-boot, trench boot, WinLoad for Microsoft's virtualization-based security with dynamic root of trust, all that kind of stuff. These are good things. I like these kind of things. I want classes on these kind of things. I almost made a TXT class back for Open Security Training 1 in the day, and I'd like to get back there eventually, but it's going to be a while. And then, of course, we've got other things that use ACMs like Intel's BootGuard, BIOSGuard. You can talk about all the various implementation issues that have occurred in vendor-specific implementations, microcode, STM, PPM. The list goes on and on. These are the good kind of things that we would like to see in some future world. If you're interested in these kind of things, well, get in touch so that we can talk about how you can help contribute. But ultimately, where I'm trying to get with some of my content that acts as prerequisites to other content is this, the idea of Architecture 5001, the design space of firmware security. I had what I consider fairly rare opportunity while I worked for Apple for 5 years to look across a bunch of different source code bases for a bunch of different vendors' firmware. And so I got to see a lot of the different design patterns that were used sometimes to good effect, where they were doing the thing right across different chips and different vendors, or sometimes where I saw the same mistakes being made over and over, or weaker architectural choices being made over and over. So I want to take what I learned from all of that cross-cutting view of the industry and put it into a class where we can start to evaluate, what are the design choices and, what is the goodness level 1, 2, and 3. Try to shoot for that 3 rather than choosing the 2. So you can see how it's not just security-specific projects or technologies, but there's a lot of fundamentals in there about things like debuggers, assembly languages, operating systems, internals, virtualization, firmware, that kind of thing. The architecture track, or system security track as I call it. But let's return to what about this leveling up existing engineers into new job classes. Well, from Open Security Training, I was mostly just showing you the sort of architectural security type design track, but the intention is to have things like learning paths on C secure programming, and that'll get us one differentiated type of engineer, or learning paths on more secure programming languages like Rust and Go that give us a different engineer. Things like secure design, and then, for instance, secure firmware design, right, and another type. And applied trusted computing, I likes me some trusted computing, and you should too. That'll give us some more engineers, and of course the reverse engineering learning paths and vulnerability exploitation and assessment learning paths. So, when I was trying to think about, leveling up, the first thing that came to mind was Mario, going from small Mario to big Mario, so I had to keep going with that particular analogy, but usually when I think about learning paths, and leveling up, I think more like the differentiated job classes of something like a Final Fantasy, and that can help me sort of visualize where I'd like to go. I want to be that engineer up there. How do I get there? What skills do I learn in order to engage in that job class? Literally. So that was the Security Engineer plus way that Open Security Training can help open source projects. What about Vulnerabilities 1001? What's that? So back when I was at Apple, I had a small side project to try to help teach the developers more about vulnerability classes so that they could avoid writing the same sort of buffer overflows over and over again. And that was used in support of a secure development sort of educational system. But as I got to the end of the class, it occurred to me that what I'm teaching people is exactly the same kind of stuff that I would teach someone who wanted to go off and learn exploitation. Open Security Training 1 had exploitation classes where exploits 1, 2, and 3 never got publicly released, but the basic point is that you would teach a vulnerability and then you'd teach how to exploit it. Teach a vulnerability, teach how to exploit it. Well, if I just refactor the code and pull out the vulnerabilities, then I can reuse it both for teaching secure development and teaching vulnerabilities and exploitation. Also, I really think that it helps for an engineer who's trying to learn secure development to know that they are being taught the same thing as an exploitation engineer. So they can kind of have a little bit more credibility to this content, knowing that it's going to be used to teach people how to exploit. And likewise, the vulnerability engineers can enjoy the fact that they're being taught the same thing as secure development, and whatever gaps, whatever content isn't covered there, well, maybe that's something that's going to be a good thing to go after. Drilling down slightly, another way that I sometimes visualize this is this idea that there's stuff that developers need to know. There's stuff that attackers, red teamers, vulnerability assessors, whatever you want to call them, stuff that attackers want to know. And there is some common material here in the middle row that both need to know. So knowledge of vulnerabilities is something that both the developers need to know and the attackers need to know. On the other hand, preventing the vulnerabilities, literally just, avoiding it, adding sanity checks to their, code, that's something that just the developers need to know. The attackers don't need to know that. So preventing is good, detecting is also good, and that is, again, a common thing. So under the assumption that you're looking at source code, we're not yet getting into reverse engineering or anything like that. Developers with source code need to know how to find it in their own code via manual inspection or with tooling, and likewise, attackers need to know how to find the vulnerabilities via manual inspection or via tooling. So common material there, and also exploit mitigations. So the mitigations is a little tricky because sometimes it matters in the context of if you're, for instance, an OS developer, you might want to add something like address-based layout randomization, or if you're a firmware developer, add address-based layout randomization. So some developers have some mitigation classes that are applicable to them just in terms of design. Other developers, user space person, it's not relevant to them unless it's something like, well, how do they opt into it? So oftentimes this section will be more about like how do you opt into the best possible mitigations that you can for your particular platform. Things like opting into stack canaries or variable auto initialization, things like that. And then after all of that, that's the kind of, vulnerabilities 1001. Then attackers go off and they learn about less common vulnerabilities. They learn about reverse engineering, vulnerability hunting, and the exploitation. And the developers learn off. Perhaps maybe the more senior developers learn about things like threat modeling. Not everyone necessarily needs to know that, but you really want your architects to know a little something about threat modeling and secure design. So what's actually in Vulnerabilities 1001 proper in a dependency ordered perspective? Well, it's the big name vulnerability classes like stack buffer overflows, heap buffer overflows, and so forth. There's other vulnerability classes that in my mind are often just sort of a way to re-unlock stack or heap buffer overflows after, someone's put in a sanity check that stops the overflow, but then you maybe find an integer overflow that re-unlocks that vulnerability class. So this is kind of the rough dependency ordering, but from an actual time perspective, you have to linearize that in some sense. So for instance, we start with stack buffer overflows. Then we provide options. You've got options, choose your own adventure. And so we are going to write up a whole bunch of different vulnerabilities, and then you, the developer, get to choose which vulnerabilities seem the most relevant to you, before then going into common material on prevention, detection, mitigation. So stack buffer overflows first, then heap buffer overflows following the exact same sort of model, then indexed out of bound access, integer overflows, and so forth. So it's not worth listing all of these things. The important thing that I want to point out here is the quote-unquote innovation of basically taking a ridiculous amount of time to write up all of these sort of things. The goal is ultimately to create 3 examples that are relevant to anyone. So for everyone, with all different developers at all different levels, I want to find 3 examples that you feel are relevant to you. Now that's hard because a lot of people work in a lot of different areas. So we're not going to get there on the first cut. So instead we have the sort of lesser goal, which is to say, well, what do we want to hit? We want to hit, developers who work in user space, kernel space, virtualization, and firmware. We want to hit people who work in an environment that's more of a server architectures, desktop architectures, mobile, or embedded. So the best case scenario is we only have to find 4 vulnerabilities so that we get 1 server, 1 desktop, 1 mobile, 1 embedded, 1 user space, kernel, virtualization, and firmware. So we play a little game of BI NGO, or alternatively BI NGO, and of course just for completeness BI NGO, and bingo was his name. So basically, we could have just these diagonals, but, we'll see what it ultimately turns into. Here's just like a rough draft early version of some of the stuff that I organized for stack buffer overflows. And you can see that, sometimes a vulnerability like CV 2021-33833 will exist in server environments and desktop environments and embedded environments. So, it kind of all depends. Different things will show up in different places. This was some user space Linux utility type thing. We've got a kernel space Linux vulnerability, and you might think, well, that should also show up in mobile because Android uses Linux kernel, but this particular vulnerability was in FireWire stuff, and as far as I know, Android phones don't support FireWire. So anyways, the point is, we find vulnerabilities, we have to write up the vulnerabilities, we try to, connect for and get, something in every row and column so that people can basically say, oh, well, I'm a user space developer on desktop systems, and I therefore am going to choose some of these examples. Now, what's not shown here is the third dimension, which is, of course, specific operating systems and vendors and stuff like that. So even if you work in user space on the desktop, maybe you're a Mac OS, Linux, or Windows developer, and so you want Mac OS, Linux, or Windows things. Sorry, we're going to try to provide a variety of different things for everyone, but again, this is a very large QA matrix, if you will, of things that we have to write up. The other thing that I'd point out is that amongst all of these vulnerabilities that the developer has a choice of what they want to see, we want to cover some in a further level of depth where they actually talk through the exploit itself, not just the vulnerability class, but the exploit itself. And so the innovation here is that you're being taught not just the vulnerability, but walked through the exploit by someone who can actually write an exploit. So sometimes we have people teaching secure programming who couldn't write an exploit if their life depended upon it. So this again helps provide additional credibility. Walking through an exploit, it shouldn't feel like it should be absolutely necessary for a developer for purposes of secure development education, but I find that it is because basically it is not at all intuitive oftentimes how a particular vulnerability, you added two numbers and they integer overflowed. Why does that lead to arbitrary code execution across the network? Well, walking through a few exploits as you go through the class, at least one through every different section, helps increase the understanding that, oh yeah, I can see how this works. It's a lot of hoops to jump through. Seems really complicated. I wouldn't necessarily want to do that as my job to have to figure out that kind of stuff all day, but it is just sort of an engineering discipline. And so, it reinforces the notion of explaining the vulnerability and root cause oftentimes takes extremely much less time than explaining the vulnerability exploitation. And so we want to cover this occasionally, not every single example. Most of them we want to just, quick, get you through it, boom, 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 cover multiple things because that helps build up your pattern recognition for the particular vulnerability root cause. But occasionally talk about how it actually works to exploit something like this. So you can see, oh yeah, if the security team says that this was probably exploitable, I guess I could see, I don't know how they got this other one to work, but, I've seen it happen, and so I know that it could happen here too. Right, so that's what I like to impress upon developers is that vulnerability exploitation is just another engineering discipline. It's something people can and do learn off on their own in their free time. And it's also something that people just do as a 9-to-5 job, day in, day out. And, teaching it is left for a future class. We don't actually teach the exploitation per se itself because that usually requires things like knowledge of assembly that we don't assume in this class. But, taking assembly, turning it into pseudocode and, showing exactly how these sort of vulnerabilities work, I find it to be highly valuable. And ultimately at the end of the class, there has been a reinforcement throughout the class for developers to program paranoid because it's not paranoid if they're really out to get you. So that was Vulnerabilities 1001. Into our final section, the moving from unsafe, super complex and closed environments to safe, simpler, and open things. So this is where, my feelings are a little more complex. They look something like this. When it comes to more secure languages and stuff like that, like Rust and Go, I want to believe. But the reality is I don't know enough yet to truly believe. I want to believe that, we could rewrite code or at least write new code in these more safe languages and avoid all the sort of problems that I'm trying to, teach how to avoid in C. But at the same time, I am well aware of, the millions and millions and tens of millions and hundreds of millions of lines of code written in these legacy languages, so that ain't going to happen overnight. And when it comes to application of those sort of things to firmware and stuff like that, I do want to believe, but at the same time I have seen how firmware development works at commercial companies, and so I know that it's not really just about like teaching the developers these new languages or any particular alternative firmware system. It really comes down to logistics. Logistics rules everything around me. And what I mean by that is the logistics of building build systems, of building QA systems, of training all of the engineers that need to actually work in the new language, logistics of debugging, and all those sort of things. So basically, I want to believe, but I know that it's going to be difficult. I think that where, things like open security training can help with this is by trying to meet people halfway and not saying like, not just throwing it over the wall and saying, oh, you should rewrite everything in Rust, right? That's not going to do anything for anyone. You should say, dear UEFI developers, let's get one UEFI developer to start writing one new module or updating an existing module in Rust or something like that. So you meet them halfway, you say, let's train one, and then if it can be shown to work for one, then we can potentially scale it by saying, we've got a whole bunch of free training classes here. The first person learned it through these classes, so teach the second and the third and the fourth through the nth person. And just in general, it feels to me that actually provided a instructor-led sort of guided tour of build environments and source code even, to say instead of just saying oh, the code is the documentation and read our man page, these kind of feel like friendlier ways to make it more realistic to ramp up on these more secure alternatives. Okay, so now to give a concrete instantiation of this idea of using open security training to teach people about better alternatives, I'm going to turn it over to Piotr.
Thanks, Zino, for bringing open security training to open source community. In my opinion, open security training to role is very important for open source firmware crowd gathered in this dev room, and I would like to explain my kind of point of view. But first, you didn't mention open security training 1, and I would like to reflect on that because it influenced 3M dev creation, and maybe it can influence others to also invest in open source firmware and promote open source firmware as a tool for building better computing systems. So before 3M Dev was created in 2015, probably open security training 1 were probably the one best in class available for free structured training for platform security. And I believe many of us watch that, many of that appreciate that. So thank you very much for creating that, because this motivated probably many people to enter the open source firmware land and security land. At that point, I was mostly interested in coreboot, watching open security training videos, looking at what Invisible Things Lab researchers published, and also watching Matthew Garrett lectures when he's swearing on UEFI. So that was great time, and that motivated me to create in 2015 3M Dev. And I would never imagine at that point that at some point I would be able to give back and contribute back to open security training too, and I'm very happy to have this chance and to have ability to give little bit back after all those years. So today firmware landscape is very complicated, and we even see some categorization of the firmware. For example, this table is rewritten from UEFI presentation about supply chain and firmware integrity measurement, and you can see in this table how many types of firmware we have. So we have firmware which can be loaded by host processor, by non-host processor, or by peripheral device. The source where it's getting the firmware from can be also in different places. It can be system firmware, it can be peripheral device, it can be non-host firmware. So you can see that how many types of firmware we have here. And that means just the environment and amounts of firmware always growing, and we're getting them more and more in our systems. But this kind of, for me, reminds me two lectures published over the last couple of years. First is a new golden age for computing architecture made by John Hennessy and David Patterson at Turing when they get Turing Award in 2017. And feel free to watch that. Like, this is a very good lecture explaining what they mean by new golden age, and why we will face more and more platform components in form of domain-specific hardware, software co-designs, which you can read from our perspective, from this room perspective, you can read as additional microcontrollers with their own firmware or with their own stack of software. Those new microcontrollers, chips, not necessarily have to be part of the existing chipset or processor, and in somehow but have to cooperate with those other components existing already in the ecosystem. So that means also a lot of additional communication, additional potential threats on the buses in the modern platforms. Second lecture is about lack of OS research, OS innovation. It is called "It's Time for Operating System to Rediscover Hardware." Very good lecture explaining why, to some extent, lack of innovation in operating system or research around operating system leads to creation of additional peripheral components, peripheral microcontrollers, which just try to handle whatever operating system cannot, don't want, or some people even say should not handle. So those are things like sensors reading, like massive sensing of the machine, out-of-band management, power management, or some acceleration. So essentially most existing OSs oversimplify underlying modern hardware, which is quite complex, and just like simplifying that cannot provide support for these features that hardware designers want to add, and they will never stop. They will also always add new features to new hardware, and since those things will never stop, we will have ever growing number of peripheral microcontrollers with firmware. Most probably this firmware will be proprietary, which is a huge problem, and we need more people to help solving that. And that's why I think is one of the reasons why OST2 is very important. So one more thing that I want to say about firmware supply chain, which I think is related with problems that we're facing, and I would like to talk about on next slides, is that many standard groups already working on firmware supply chain issues. Like Trusted Computing Group got firmware integrity measurement spec, IETF working on remote attestation related with, of course, attesting measurements gathered in the TPM, and there are many others. There is SPDM from specification from the MTF. OCB also got their own requirements and recommendations. So all those groups trying to do something with ever growing number of proprietary closed source hard to verify components. So that's how modern system look like. So we have firmware everywhere. Essentially, on this slide we see that almost every component, PCI Express, GPU, audio, sensors, chipset, everything got firmware in some form. CPU got microcode, chipset got CSME. In TPM also we got firmware which can have bugs like ROCA. So USB devices connected to our computers also most likely got some firmware. So that's the state right now. We have a lot of firmware to take care about. But what does it mean? So that means most of this firmware is closed source. There is very little of that open, and there is a lot of work around open sourcing the ecosystem. So computing solutions that we can trust are right now either very old, because like old KGPD16, which can work without microcode, without any additional PSP, proprietary firmware components, or expensive like OpenPower, which is very expensive hardware despite being trustworthy and open. Without open source firmware, it will be very hard to create trustworthy solution needed for our daily use and all levels of computing from our IoT devices through firewalls and ending on our servers and through laptops and workstations that we need for our daily job. Without new software engineers interested in this kind of development, open source, low level security, privacy aware, and privacy concerned, it's very hard to build strong ecosystem that could sustain all this open sourcing effort and all this maintenance effort around this component. So I believe open security training give us a chance to share knowledge in very efficient way. we can use privacy respecting privacy respecting and trustworthy solutions to share the knowledge and to try to help new beginners quicker ramp up, to build better awareness so people themselves can flash the machines and put the open source on their hardware. And I think this should lead to better adoption of open source firmware and better awareness in the ecosystem. And on the other side, when we don't have to take care about all the basic questions, we can do something more complex. So we can focus on harder problems, because the education of the new generation is partially handled by free and open ecosystem of open security training too. What areas I think are the most important for the open source firmware community? Definitely firmware frameworks, coreboot, UEFI, you name your framework. This could be ORBoot or many other which are very promising, like uroot, Linux boot related development. So the other area which is very important are advanced hardware security features of modern platforms, trusted computing, which I believe is very important. And finally, when everything else fails, we have to reverse engineer stuff, because sometimes like vendors do not cooperate, do not provide documentation, and we want to provide interoperability for our hardware. So this section should be a little bit about 3M contribution and case study. So we did the contribution already, the ARC 4031, which is coreboot introductory material. We're planning the next one. We tried to do hands-on, but it's not so easy to record hardware and precise hardware elements on the lowest level, and show you how to hook things. So this needs some additional logistics. Definitely recording something with QEMU was way easier. But anyway, this is something that we have to solve, and would like to do that in this year and provide more trainings. So how we made contribution to open security training 2 possible. So one thing that we did, we contributed existing training materials, or we redesigned existing training materials to feed the quality of open security training 2. Second thing, we're trying to align any commercial training roadmap or opportunity to maximize creation of Creative Commons content. Thanks to that, we can contribute that to open security training. Then we're trying to reuse material from those commercial trainings and for those. So we reuse existing material in OST2 for commercial training, and of course, like giving correct attribution. That also improve the situation, because we can use the margin that left from materials that we don't have to create to contribute back to OST2. And if we focus on value added in-person and remote live trainings, then we can generate some additional revenue that can be used as a source for contribution to open security training. Finally, we leverage conference content that we delivered over the last years, and that also is good source of material. Then we trying to move all the new employee trainings to open security training, and we convert internal analysis researches and reports into training materials. So that's it. And we try to engage as many people as possible from the team, either from logistics side or just from sanity check side, from management point of view. But also the key point, of course, are engineers, which help us create guts of the trainings. Finally, like what's our plans? What's 3M contribution roadmap for this year? So on the bottom of the timeline, of the top of the timeline, you see ARC 4021, which is introductory UEFI. The material is ready. It is very close to release. I believe it's a matter of finishing the reviews and starting record videos, and that's it. And we publishing. Then 4201 UEFI secure boot. Those also Zeno mentioned in his slides, but I want to make sure that it is confirmed or also from my side. This one is also, material is ready, we're waiting for review. Review will be finished, we will publish material. But those will be mostly theoretical, we don't have practical parts yet to that. But I believe sooner or later we will add QEMU, we will see how this will go. And 4032, so hands-on, coreboot hands-on, many people ask about that. Unfortunately, this is not yet done, the material is quite advanced, but we have to solve this recording problems of hardware and so on. On the bottom of the time we see this code complete one, which is the Intel boot guard, Intel ME, Intel TXT. Those are code complete. They have quite a lot of material already. Of course, adding exercises and practical labs to that would be very helpful. But we will see if this can fit in this year. And then finally we have things which are in very early development, like ARC 3001, which is virtualization. Definitely there are better people knowing virtualization better than us to proceed with that training, but we already created some basic material related to that, and maybe we will continue that if there will be no one interested in contributing. And then the ARC 3023, which is UEFI internals 1, and there will be probably UEFI internals 2. Those are that one is very extensive. It has a lot of chapters. Right now we just created capsule update, which is not enough for doing some presentation, but we will see, maybe in this year we can do more. So we would like to focus in 2022 more on training materials than on conferences. So most likely we will be less available on the conferences, but we will try to provide more materials on open security training. If you would like to speed up things, if you like some of these trainings and you would like to see it faster, definitely sponsorship could help, and recommending us to train in your organization, that would be also very helpful, because you can be sure that part of that will go to open source community in form of training materials. And feel free to send us wish lists and feedback, because that is always helpful to know what you think about this project and how we can improve it. So thank you, that's it from me, and I'm giving back to Zino.
So that was an example of how we can use open security training to bootstrap additional engineering capacity in promising technologies. And with that, those were our 4 different ways that I thought of for now of how open security training can help open source developers. So that's how we can help you, but I'm sure what you really wanted to know is, how can you help us? Well, it's pretty simple. If you see a class you like, go take it and provide feedback to the instructor. We also, of course, always announce beta classes on our social media, things like Twitter, LinkedIn, and so forth. And so if you see an advertisement for a beta class, one of these aspirational classes that I said we'd like to see in the future, go ahead and sign up for that, because those are the things that really help improve the classes the most. You can, of course, let other people know about open security training too, because the more people know, the more people can benefit. And of course, we can find more instructors for the future that way as well. We've only relaunched Open Security Training 2 back in July of 2021, so it's been less than a year at the time of recording. And the current plan for sustaining OST2 is what you might call the Linux kernel model of getting corporate sponsorship and help. So if you have a company that you think would be interested in supporting us, please get in touch. And finally, of course, what we really want is people who contribute classes. There's a whole bunch of classes, a whole bunch of cool things that we know would be awesome to have, but we need instructors because we can't do this all ourselves, and the more the merrier. And with that, thanks for watching.